Okay, hello. This is Dr. Osman Al Hassan. I'm going to be solving quiz 1 quiz that we wrote about 2 to 3 months ago. Right? So I'll be solving for CY1B, right? Cybersecurity 1B. I've already solved for other quizzes, right? For other programs. For example, I solved quiz 1 of mathematical students, then computer students, right? Meaning group A and group B of computer students, and then IS students, right? Information system students. So I've solved their quizzes and I've uploaded the solution into my YouTube channel, right? So this is the name of my YouTube channel. It's here. You can see that it's Al Hassan Wiela, PhD. So you can find the solution of other quizzes on this YouTube channel. So let's get started. Okay. Now, so we have quiz 1. We were given 3 questions. We have question 1, 2, and 3. So you can see that for question 1, we have you have been asked to find time, and then this 1B talks about finding the electrons, number of electrons, and then question 2, you have to find the currents in figure 1, right? So this is our figure 1 here. This is figure 1. You have to find the current, and then for figure 2, you have to find the power dissipated by the 2 ohms resistor, meaning this is a 2 ohm resistor. You have to find the power. And when it comes to question 2, I'm going to solve question 2 using branch current method, right? And then question 3, I'll be using source transformation method to solve it. This is because I want to ensure that there is diversity in the solution, right? The quizzes that I've already solved, I've used different methods and theorems, right? So this is to ensure that students have an overall view of the course material, right? And you're also going to go a long way to help you understand all the different methods and theorems that are out there, right? So let's start with question 1. So I have here question 1. This is my question 1. So question 1A, a battery of 40 volts supplies a current of 5 amps and produces 72 kilojoules of energy. How long does it take to produce this amount of energy, right? How long does it take to produce this amount of energy? You can see that we are given, from the question, we are given voltage. So I can write voltage here to be 40 volts. And then we are also given current to be 5 amps. Then energy, right? We have energy here, which is equals to 72 kilojoules, which is the same as 72 times 10 to the power 3 joules, which is going to be equals to 72,000 joules. So we have 72,000 joules of energy produced. Now we are asked to find the time it takes to produce this amount of energy. Now to find the time, first we start by trying to write the formula, right? In terms of energy, power. We know that power is the ability to do work, right? Or the rate of doing work. So work then is a form of energy. So I can write power P to be equals to energy over what? Time. Right? So you can see that with this, I've already have time here. Right? I can make time here the subject, so we can get time to be equals to energy over what? Power. So I have my time. At the same time, we know that energy, power can also be equals to what? The current times what? Voltage, right? So if I know the current and the voltage, you multiply them, then you get the power. So we can replace this, right? Let's say this was equation 1 and this is equation 2. You can replace equation right? Replace equation 2, right? In equation, let's say 1, right? So that we get time to be equals to, so the time here is going to be equals to energy over power, which is now what? Current times voltage. So now we know that energy is 72,000, and then the voltage is giving us 40, then times the current, which is 5, right? 5 amps. So you can see that with this, if you do the division, right, here we can 0 here can cancel here, so we have here we what? 20, right? So here is 20, right? So let me just take 7,200 divided by 20. So that will give us 360 seconds. Remember here it has to be in seconds. The time that you are going to will be in seconds. Now you can change that to what? 2 minutes. So you just divide 360 seconds by what? 60, and then that is going to give us minutes. That will be what? 6 minutes, right? So we get 6 minutes for this. Now that is the time. So let's go to the second. Let's go to 1B. Question 1B. We have question 1B here. Here we are asked to find you are asked to find how many electrons are being transferred. So you are given a current of what? 6 amps flows for what? 2 minutes, right? 2 minutes here. How many electrons are being transferred? So we can see that from the question we are given, I'm going to write the parameters that I'm giving. We are giving current to be equals to 6 amps. The time here is what? 2 minutes. Right? So 2 minutes is going to be what? 2 times 60. Right? So time here is going to give me 120 seconds. Right? So time is 120 seconds. Now you have to find how many electrons are being transferred. So to find this electron, that first we have to try and get the charge, right? How much charge or magnitude of charge is going to be produced as a result of the flow of current, because we know current is what? The flow of charges. So the formula is going to be what? Charge over what? Time, right? So from this we make charge the subject, so we get current times time. So if we were to replace the values, you can see that we have 6 times 120, right? So charge here is going to give me 120 by 6. We get 7 120, right? We get 720 coulombs of charge, right? The unit here, coulombs. Now once I've gotten the coulombs of charge, from, if you look at the end of what question 1b, you can see that we are being told that one electron, right? So if I have one electron, it contains 1.602 times 10 to the power minus 19 coulomb of charge, right? So now if I have 720 coulombs of charge, what is going to be what? The number of electrons, right? Let me use n here to represent the number of electrons here, or you can even use x, it doesn't matter. I'm using n here just to represent the number of electrons. So we cross multiply. By cross multiplication, you realize this will multiply by this, right? And this by this, then you divide by n, by 1.6. So first I'm going to, when you cross multiply, we have 1.602 times 10 to the power minus 19 n, right? Cross multiply here, that will be equals to now 72. This is by 1, so you get to 70. It's 720 here. So you can see now we divide, so we get n here to be equals to 720 divided by 1.602 times 10 to the power minus 19. So now when you do the division, right, when you do the division, you are going to get this thing to be, you get the answer here to be equals to 4.4938 times 10 to the power 21, right? Electrons here. So I can come and write it very clearly here. We get 4.4938 times 10 to the power 21 electrons. So this is the amount of electrons that are going to be transferred. So that is for question 1b. Now let's move on to the next question, which is question 2. So we have here question 2. So I have my question 2 here. So for question 2, you have been asked to find the current in figure 1. So I have figure 1 here. We have to find the current. So like I said earlier, this I'm going to be using a branch current method. So here we have branch current method, right? So you have here to be branch current method. So even here, let me try and then indicate our final answers that we got for question 1. Then we have here to be 6 minutes as our final, was our final answer. Now we have question 1. You have to find the current, and we are going to be using branch current method. So with branch current method, so what we tend to do is that we tend to assign current to each branch. So you can see that we have 3 branches, right? We have one here. This is one branch. We have another one here. Then we have another one here, right? So we have 3 branches. So we have 3 branches. So meaning each of these branch we are going to assign current. So for the first branch, I'm going to assign the current I1. The second branch here we have I2, and then the third one we have I3. So I've assigned the current. Now I'm going to indicate the direction. So I'll indicate the direction relative to the voltage source that we have. You can see that we have 30 volts here. So because we have here negative here to positive, meaning the terminals, so I'm going to indicate my current starting from negative and going to positive. So we indicate the direction to be going this way. Now this is what the current here. You can see that here is a junction. Because here is a junction, is going to be divided. So I'll make sure that I2 is leaving the node, and I3 is also leaving the node. So we have a circuit diagram of this. Once I've done this, now I can apply Kirchhoff voltage law to each loop, right? So here we can see that we have quite a number of loops here. You can see we can have one here. A loop here just meaning a closed circuit, right? So we can have a closed circuit of this one, which is 1. We can have another one, right, which is also going to be this way. We can even have a third one, right? A third one that is going to be this way, right? Third one. Can have a third one here. Since we are using branch current method, we can even use a third one, because here, though it's not an independent loop, but branch current you can use it. If we were using mesh analysis, we couldn't use a third loop because it's not an independent loop, right? Because you can see within the third loop here you have another loop within it. So by branch current method we can apply Kirchhoff voltage law to that, to loop 3 as well. So now let's get started with the method. Once I've done this, I'm going to now write the equation, right? So I'll have here applying, here we have Kirchhoff voltage law to loop 1, right? This is my loop 1 here. You can see here I'll be moving clockwise, right? So we are moving from the 30 volts, right, clockwise back to the same place. Now again I'm going to indicate, I'll go ahead now and indicate the polarities on the resistors, right? The polarities on the resistors. So if I'm moving clockwise, so here you can see I1 here. We have I1 entering the first terminal of the 3 ohm resistor here. So where it enters, where we consider that we positive. When the current leaves here, that will be negative. So here to the same thing, you are going clockwise. So here too will be positive. Current is entering. Here too will be I2, right? I have my I2 here as well. And when it enter here, we have, when it leave negative, here to positive, and I have negative here as well. So you can see that for my first loop, right, you have this kind of circuit. You can even go ahead and indicate the other polarities, right, on this one. Here too also we can see the current entering. So we have plus here. When it leaves here is negative. The same applies to one. Positive here. So with this, we can even further reduce this circuit diagram, right? Actually, let me do that. That will simplify that way. I'll reduce it by simplifying the 5 ohms and 2 ohms here, because you can see the same current I2 is passing through 5 ohms here, and then the 2 ohms that I have here, right? So I'm going to simplify that because it's the same current, so you can add 5 and 2 so that you get 7. So I can get this circuit diagram of this nature. So I can have my 30 volts here, have our 2 ohms. Then with this, I have this now, and then the same thing applied to this 4 ohms and then 6 ohms. The same current is going to pass in through them, so we can add that part as well, so that we have this simplified circuit diagram. So now I have here to be 3 ohms, then this one will be 7 ohms, and then here is what, 10 ohms, right? 4 plus V. So now we go back. Now I'm going to indicate now my current I1, here is I2, and here is I3. You can see this is a much simplified version of what figure 1. Now I'm going to now apply Kirchhoff voltage law to loop 1 here, right? And then remember here I'll be applying to the loop 3, but I'll do that one later. Now with this application, you can see indicating the bar, we have here plus, here minus, here plus, minus. So now I'm going to write the equation. So you can see here minus here to positive will be rise, so we have 30. Let me use a different color here. We have here to be 30. Here will be drop, we have plus to minus here, so that will be drop. So I have 3I1. Here too, you can see we are going clockwise for this loop 1 here. We have here to what, drop, so we have minus 7. That's I2 here. Then we go back, we are moving, come back to the same, so we have here now 0. So if we were to simplify this, right, so you can see that if you move 30 across the equal sign, we end up having positive I1 plus 7 I2 equals to what, 30, right? So we label this as equation 1. So this is my first equation. Now let's try and get the second equation, right? Because here we can see that we have 3 variables, I1 and I2 and I3. Those are the variables that we are interested in calculating for. That's the current. So in order to solve for 3 variables, we need 3 equations. So this is our first equation. So now I have to get 2 extra equations. So to get the second equation, like I said, I'll be using what, the third loop, right, that you can have, which is this one. Imagine we are moving clockwise. This time we are moving this way, okay? So we are moving the whole way like this. So with this here, like Kirchhoff law to loop 3. Okay, let me make this 3. That's my third loop. I'm considering it to be loop 3. It's labeling, right? Here will be loop 3. Okay. So with this, I have this equation here to be. Again, you can see here I'm going to have 30, which is going to be rise. Here again I have my what, 3, because we are moving this way, 3. Then we come to this part here. Again we now have minus 10 I3 equals to 0. So we simplify this the same way we did. So we end up here 3 I1 plus 10 I3 equals to what, 30. So this is our equation 2. Now let's get the third equation. The third equation here, we can get it by applying Kirchhoff voltage law to a node. So you can see here we have a node here. This is a node, let's say it's node A. At this node you can see I1 is entering, I2 and I3 are leaving. So I can write the equation here to be Kirchhoff current law at node A. We are going to get I1 will be equals to, the sum of current entering will be equals to the sum of current leaving. So we get this equation. Now this is going to be our third equation, so equation 3. Now we can solve for I1, I2 and I3. So you can just use your calculator to calculate for the variables here straightforward, but I will not be using my calculator. So I'm going to solve this using maybe substitution or elimination method. Let's say, let me look at my equations again. Equation 1 here, you can see we have I1, I2. Here we have I3, I1, I3 here. All right. So with this, I'm going to replace, I'll make equation 3 the subject and replace it in equation, let's say equation 2. So I'm making equation 1, equation 3 the subject, I3 the subject, so that we have I1 minus I2, equation 4. See, once I've done that, you can now put equation 4 into equation 2. So we have equation 1, equation 2 being what? 3 I1 plus 10 here will be equals to I1 minus I2, which is going to be equals to 30. So here we cross multiply, so we have 3 I1 plus 10 I1 minus 10 I2 here equals to 30. So when you simplify, we get 13 I1 minus 10 I2 equals to 30. So we label this as equation 5, right? Equation 5. So we can now see that if we were to compare equation 5 here, equation 1, we have I1, I2 in them, and then here too we have I1, I2, right, in both equations. Now to solve for this, equation 1 is here, so let me write equation 1 below this. Equation 1 is what we have 3 I1 plus, right, 7 I2 equals to what? 30. Equation 1. Now I'm going to solve this using elimination method. So in using elimination method, let me try and eliminate I2, right? We have to eliminate I2, because yes, so meaning I'm going to multiply equation 1 here by that will be by 7, right? Equation 1 here by 10, right? So if we're to do that, I'm going to now get equation this by 7, so meaning 7 times 13 is going to be -1. -1 I1 minus here, meaning this will be 70, right? 70 I2, that is going to be 7 times 30 will be 210, right? Let me label this as equation 6, right? Now we multiply equation 1 by 10, so we get here to be 30 I1, 30, meaning this you get 70. I2 here will be what, 300, right? 30 times 10 will be what, 300. Get here to equation 7. So we've gotten this. You can see that now I can add, right? You can just add these two equations. So if we were to do that, you can see that with the addition I have 90 plus 30, 91 plus 30. That will give me 121 I1. Here when you add, right, you get 0 plus 0 here. Here we are adding as well. So we have 210 plus 300. That will give us 510, right? So now I1 will simply is going to be equal to 510 divided by 121. So we have this by 121. So we get this to be 4.214 amps, right? We get this 4.21 amps for this equation. So you can see we've calculated for what, I1, right? So let me look back again. Is there any mistake here that I did? So let's just check for, I think, yeah, so we are good to go. Yes, so we get so let me, it will be 5 here because abbreviation here 2.15 amps, right? You round this off. Okay. Now we now move to what? Let's try and get I2 and I3. So we can get I2 by replacing what? Equation 1 by I1 equation 1 and solving for what? I2. So when you do that, so you make I2 the subject in equation 1, so that will be equals to what? I think when you do this, you should get I2 should be equals to 30 minus, is it, let me look at equation 1 again. I have here, okay, 30 should be minus 3 I1 over what? 10. 3 I1 over 10. So this will be 30. 3 times 4.215 divided this by 10. So this is supposed to give me 30 minus this 3 times 4.215 divided by 10, right? So we have 7 point, I2 should be 7.36 amps. Okay, now we get I3. We know I3 is going to be I1 minus I2, so I have 4.215 minus 1.736. So this gave me times here minus 1 plus 4.215. So that will give me 2.478 amps. So we get this as our I1, I2, and then I3, right? So we get this as our answers. So I have here to be, let me make this No. Yes, it's 2.479, right? It should be 979 here, right? 79. Okay. So we get this as our answer. So I have now my I3 is here, I2 is also here, and then my I1. So let's go to the next question, which is question 3. Now question 3 here, I'll be using source transformation. Source transformation to solve for this. Using source transformation here to solve. So I have source transformation. Now when you come to source transformation, you can see that we are given this circuit diagram, right? So source transformation just means that you can if you have for example, if I have a voltage, right? If I have a voltage here in series with a resistor, let's say R here, and then I have here, okay, let me use RS and then VS, right? You can transform this to a current source, right? So IS here in parallel with the same thing that we have, meaning RS, right, with the resistor, right? So if you have a voltage source in series with a resistor, you can transform it to a current source in parallel with the same resistor. That's what the source transformation, and it's vice versa, right? So meaning if I have a current source in parallel with a resistor, you can transform that to a voltage source in series with a resistor. So using this concept, we are asked to find the power dissipated by 2 ohm resistor. You know that power here is going to be equals to, meaning the 2 ohms will be equals to the current which is passing through the 2 ohms square times its resistance, which is 2 ohms. So again, this is the power. So meaning to get this, I have to get the current. So let's get the current which is passing through this, right? 2 ohms. To solve this using source transformation here, what we try and do is that you can see I have 2 voltage sources. We have 9 volts and 24 volts. You can see these are 9 volts here is in series with 7 ohms, and then you can see that 2 volts here is in series with 3 ohms and 4 ohms. So we can transform this to a current sources, because once we have current sources, we can do the algebraic sum of the current, and that will allow us to get the current which is passing through I2. So to do this, we are going to convert this part here, right, to a current source in parallel with the resistors that we have. So we can transform this. So you can see these are 2 resistors, 3 ohms and 4 ohms. So we add that part, right? So meaning this will be 5. The sum of this, meaning 3 plus 4 here will give us 7, right? 7 ohms. So we have now 24 in parallel with 7 ohms, and we transform that. So meaning I have here my current source here is going to now be in parallel with 7 ohms here. Now we have to now get this current which is going to be here, and to find this current we simply take the voltage here 24 divided by the resistance here. So this will give me So to find this, you can write here maybe IS1, right? It will be what? VS1 here over, let's say RS1. So we get 24 divided by 7. So that will give us 24 divided by, that should give us 3, right? So that will give us 3 amps for this. Right. $24 rather. Sorry, you have 24. No, 21. It's 24 divided by 7. That will give us 3.42. Right, 3 point here will be 3 point. Let me write this way. 3.429. I'm going to make 429 amps, right, for this. Now after this, I'll bring the 2 ohms. That one is not being changed at all. 2 ohms. So you can see this part to have what? The same scenario compared to the first one. So that part will be going to be transformed. So I'm going to have my current here, right? Then it's going to now be in parallel what? Again, here is 7. I have 7 ohms here. Then you connect this, right? Now again, by this time we have 9 ohms. The voltage here is 9 volts rather. So that means IS2 here is going to be equals to 9 divided by 7. So 9 divided by 7, that will give me what? 1 point. So we get this current here to be 1.286 amps. So we've gotten this. Once we have done this, you can see that I can do algebraic sum, because here the node here is the same, right? This node that we have here, these nodes are all the same, and this current is entering the node, this one is also entering the node. So I can do that, and they are all in the same direction, right? So they are all possible. So the algebraic sum here, right, can do the algebraic sum and also simplify the circuit diagram. Let me write this one. This one we have 1.28. So I can sketch another circuit diagram here, right, so that we have here to be. So after we've done the algebraic, meaning this plus this, right, algebraic sum. So here we do the algebraic sum. So I'm just going to get, we add, so I'm going 1.286 plus 3.429. So that will give me 4.715. So we can, after we've done the algebraic sum, I'm now going to have my current source here to be 4.715 amps. Now I have here to be 7 ohms. I have my 2 ohms, and then we have another 7 ohms as well. So now I have this as my, let's see. Now I'm going to do calculate. We're entering the current which is passing through this, right? Maybe we can even label straightforward, mean current 2 ohms, right? Current that is passing through on resistor. This is what I'm interested in. So here I'm going to use current division straightforward, all right? And to use current division here, because here we are having a node here, this is a node, and this is the current that is entering. So that's the main current or the total current, which is 4.175, right? This is 1.175 here. So I'm using current division. So you can see here I'm having 3 resistors in parallel, 7 ohms, 2 ohms, and 7 ohms again. So to get the use current division straightforward, we are going to, so we are entering the which by 2 ohms. So meaning we take here the product of what the other other resistors, right? 7 ohms. So I'll multiply here 7 by 7, right? Then when you come here, we take the watts. We use a combination by taking 2 at a time. So I'll take first 7 and 2 times this, right? So that will be 7 times this plus here 7 plus what? Plus 7 plus 7 times 7, then plus the last one, which is, so I've taken this, and this will be what? Sum 2 times 7, then times what? The voltage, the current rather, which is here 4.715. So with this, I get this to be close to 3 amps, right? So now the power here is going to be current, which is 3 square times what? The resistance, which is 2, right? So that will be 18 watts. So we get the answer here to be 18 watts. So this is the solution. So let me indicate these ones here. Now we got, right? These ones, right? And then this as well. Okay. So that was the solution for quiz 1.